All right, hi everyone, and welcome back. So if you're watching this video, you're probably looking for some information about organic methods of communication. So things like molecular formula, structural formula, condensed formula, or the geometric line formula. So depending on which one you use, you can communicate the structure of your compound differently. Okay, some of them are really useful, and others, not so much. Just depends on which particular compound. So the compound I chose for today is pentane, C5H12. So we'll start off with molecular formula first. So there's the molecular formula of pentane, C5H12. Now this really doesn't tell me a lot about the structure of the compound. The only thing I know for certain is that there's 5 carbons and 12 hydrogen. But how they're arranged structurally is not communicated in this method, right? So all I know is basically what atoms are present. It's not really going to tell me a whole lot. A structural formula will tell me, what is connected to what, which atoms are connected to which atoms, okay, and what they look like, sort of three-dimensionally, I guess. So a structural formula does a little bit better of a job of showing what atoms are connected to each other. So I'm going to draw C5H12 as a straight chain molecule. So it would look like this, 5 carbon in a row, and then hydrogens attached to the carbon, 3 on the terminal ends, 3 on each terminal carbon, and then 2 on each interstitial in between carbons. Okay, so there's my 12. Now some people like to see the hydrogens attached here, every single bond. I personally don't. I think it's a bit of a overkill. If there was something like a nitrogen or an oxygen attached, of course, I would show that. You would have to show that. But for the hydrogens, you don't necessarily have to do that. If it's not written in, it's understood that it's hydrogen, okay? And if you want to show them, that's fine. It just takes a little bit longer to draw your structure. Okay, so there's the structural formula of C5H12, or at least one structural formula of C5H12. C5H12 actually has 3 different structural formulas possible. This would be the straight chain molecule N-pentane. You could also have 4 in a row, 4 carbons in a row, like this, and 1 carbon as a branch. That's the 5th. Again, there's still 12 hydrogen attached here. Okay, but it's got a different structure, a different structural formula. So that's another way you could draw C5H12, but there's actually a third. So 3 carbons in a row. 1, 2, 3, and this time 2 branches. Okay. Also, all the hydrogens attached. Each carbon here on the outside has 3. So there's our C5H12. So molecular formula C5H12 really doesn't tell me anything structure-wise, okay? Because as you can see, there are 3 different structures possible for C5H12. And if all you know is molecular formula, how do you know which one it is? Each of these 3 compounds has a different melting point, boiling point, viscosity, all different physical properties. They're not the same compounds, so they can't be the same chemically or physically. They're going to be different, okay? That's why molecular formula is really not the best way of communicating a structure for organic. Now, if you want to make this a little bit more shorthand, we'll say, you can use the condensed formula. So a condensed formula, we kind of break it into segments. CH3, so here on the left we would write it as CH3, and then CH2 for the next piece, CH2, CH2, and CH3. This would be the condensed formula. It's a little bit faster to write than the full structure formula. Okay, it does still show me that it's 5 carbons in a row, and 3 hydrogens on the terminal end and 2 on each interstitial. So, you know, no different really between condensed and then the full structure formula, just more of a time restraint really. It's a little bit faster to write it as a condensed formula. The third way that you can show structure formula is the geometric line system, and that's the one that I prefer. That's the one that I find the easiest. Every carbon is represented by a point, and then we connect them with lines. Amazing, right? So 5 in a row, I would draw 1, 2, 3, 4, 5 like this, and again, every point is a carbon. So there's 1, 2, 3, 4, 5 in a row. If I wanted to show this 4 with a branch, I would do 1, 2, 3, 4, and then a branch. There's number 5 up there, right? So every point is considered a carbon. If I wanted to show 3 with the 2 branches, 1, 2, 3, 1, and 2. Okay. Now the geometric formula is definitely the quickest, the easiest one I find personally. You know, it's just more of a time saver, I think, really. A lot of people find the geometric system to be a little confusing, so it really just depends on how well and how easy, how much you practice them. If you want to get good at them, I would suggest, you know, practicing most of your organic structures with the line system. When we do geometric formula, we don't show any of the hydrogens, of course. So even though each carbon has like the 3 hydrogens on the end and inside carbons are 2, we don't show them, but we would show any other atom, nitrogen, oxygen, you know, chlorine, fluorine, whatever. Anything else we do show, but we don't show any of the hydrogens. Now, for all of these structures, it's important to be able to do all 3 of them, so make sure you practice how to do a structure formula like that, a condensed like this, and also the line system, because you will see all 3 in quizzes and final exam and workbook and notes and all that stuff, so it's important to know how to read and understand each one. But then you choose which one you like the best. That's the one you're going to use, the one you're most comfortable with when you're drawing your structures and writing your organic reactions. But make sure that you do understand specifically the line system, because that's the one that often gives most people, you know, an issue. But in terms of their communication, structures, condensed, or line system, all show me the exact same thing. It shows me what atoms are connected to which ones and what their 3-dimensional sort of space is. Molecular formula gives me very little information initially. All I know is what atoms are present, and that's it. When you're looking at drawing your reactions and drawing your structures, definitely go for, you know, condensed, geometric, or structure formula as opposed to molecular formula. Molecular formula is really not going to, you know, tell you very much information. All right, that's it for this video. If you have any questions, please reach out and let me know. Good luck practicing all of your structures, and we'll see you next time. Bye.